Red giant stars. So where we've left off, we had an orange giant, and this had a helium core that's inert. Whoops. And a hydrogen fusion shell. And of course, hydrogen fusion is making helium. So we've got this helium being produced in the shell that's getting added to the core. So it's dumping more and more helium onto that core, making it heavier and heavier. That core, of course, is going to collapse since it has no energy production to push out. And so gravity is going to win, and that core is going to collapse inward. And as we keep seeing, when you collapse a gas, it's going to get hotter. So we have this helium getting hotter and hotter and hotter until it's hot enough for helium fusion. And that temperature is about 100 million Kelvin. Now recall, for the hydrogen fusion, it was 10 million Kelvin. So it's now 10 times hotter than our main sequence. So our core is much, much hotter than it was originally. And so now, of course, we've got energy pushing out. And so that's going to balance the gravity pulling in, and our collapse will stop again. So whenever you have energy production, that's going to balance gravity, and it's going to be stable. So we're back to being stable. Now, hydrogen fusion made helium. Helium fusion makes carbon and oxygen. C is carbon, O is oxygen. When our universe began, hydrogen and helium were, for all intents and purposes, the only elements present. All elements other than hydrogen and helium are made in stars. So that means the elements in your body came from stars. The carbon, where do we use carbon? Carbon's in our DNA. We are carbon-based life forms. Oxygen, of course, we breathe oxygen. So the oxygen you're breathing, the carbon in your DNA, at one time was inside of a star. That's how it was made. And it was after the star exploded that those elements were then spread back into the universe and ultimately were used to make our sun, our planet, and the life that developed on this planet, and ultimately you. So we are made of things that came out of stars. We still have hydrogen fusion, so that hasn't gone away. So we've still got this going on. So now we have two kinds of energy instead of just one. So now we've got both helium fusion and hydrogen fusion going on. which means we've got a lot more energy pushing out on our star than we did before. So it's going to get even bigger. Here we see Aldebaran, a star that would be going through this stage, and how big that is compared to our Sun. When our Sun goes through this stage, this will be out to about the orbit of Mars. So Earth will be inside the Sun at this point. So this is a red giant. Red because now it's expanded more, so it's even cooler. And of course giant because it's big. So our key component of a red giant, helium fusion in the core and hydrogen fusion in the shell. That is a red giant. Now in the case of our Sun, that's as far as it's going to go. Higher mass stars, as we will see, will go beyond this in terms of giant stages. But for smaller stars like our Sun, this is it until we run out of helium. And then we'll go into the next stage for both types, whether it's high mass or low mass stars. But this is a red giant.